Friends, engineers, architects, consultant engineers, and all others. Once again into VK Jan Sarki MEP classes. In this particular module, we'll discuss types of artificial illumination sources. Okay. Friends, electrical lamps. The source of artificial illumination can be of four types. The first one is incandescent lamp. Second is high intensity discharge lamps, HID. Third is induction lamp, and fourth is light emitting the LED type. In the diagram on left hand side, the lamps have been classified in these four uh, incandescent, HID, induction, and solid state, that is light emitting diode. Now incandescent lamp can be of two types. Conventional Lattu type, second is halogen type. HID discharge lamp can be of several types. First one is of mercury vapor, which once again in term classified as low pressure or high pressure. The low pressure mercury vapor lamp is known as fluorescent type, and the fluorescent type can be tubular, circular or compact. And in the tubular type, T16, T12, T and T8 and T5 according to their diameter in mm. The next one category is metal halide. Metal halide can also be tubular, and in tubular it may be single-ended or double-ended. And in case of metal halide, second category is lamp type. Similarly, in sodium we have HPMV or LPMV, and the solid state is popularly known as light emitting diode. Friends, this particular table describes the the characteristics of commonly used luminaries. It has first column which describes type of lamp, second column shows lumens range and average required. The fourth column dictates color rendering index quality. The fifth column shows typical application, and sixth column typical life hours, how many hours the particular lamp will survive. We'll discuss some of them. The incandescent category has a range of 8 to 18 lumen per watt. Average is 14. Color rendering index is excellent, and this is deployed in homes, restaurants, general lighting, emergency lighting, and it survives only 1000 hours. We'll discuss another category, fluorescent lamp, of which range is 56 to 60 lumens per watt, and average is 50. So this is fourfold, at least fourfold advantage here. The color rendering index is good with respect to coating, and it is deployed in offices, shops, hospitals and homes. Typical life is 5000 hours, which is 5 times as compared to incandescent lamp. Compact fluorescent lamp CFL are now outdated. We discuss now high pressure HPMV lamps, which have a range of 44 to 57 lumen per watt, average being 50. Color rendering is fair. This is deployed in general lighting in factories, garages, car parking, food, flood lighting. Typical life is 5000 hours, equal to fluorescent lamp. Halogen lamps are very low in power quality. It gives only 18 to 24 lumens per watt with average of 20. Color rendering index is excellent. That is why it is deployed in photography. All your mobile camera, they use halogen lamp of a smaller size. Typical application is display, flood lighting, stadium, exhibition grounds, construction areas, and it is 2000 to 4000 hours life. The mainly halogen lamp is deployed as secondary source of uh, lighting, flood lighting in case of cricket matches, and for that reason any type of sports match. They are kept as standby because their striking time is very low. So if in any case, if the metal halide lamp fails, generally sports lighting is done through metal halide lamp. If they fail, then halogen lamp takes over ultimately. The sodium vapor lamps have very high uh, power capacity, ranging from 67 to 121 lumen per watt with average of 90, but color quality is fair. So it is used in general lighting in factories, warehouses, street lighting, and life is very high, 6000 to 12,000 hours. The low pressure sodium vapor SOX is having the highest power quality, that is 101 to 175 lumen per watt with average of 150. Color characteristic is very poor and monotonous. It is used in roadways, tunnels, canals, street lighting. It is used in such area where human presence is required for very short time. So all uh, railway stations, yard, yard marshalling, even for this rail metro system, and it has a high life quality. Friends, this table compare uh, many subcategories of type of lamps: compact fluorescent, linear fluorescent, T5HO. induction lamps, metal halide, high pressure sodium vapor, low pressure sodium vapor, that is fluorescent tube, mercury vapor, LED and tungsten halogen lamps, and gives their efficacy in lumen per watt. Lamp life is also given color temperature, electrode temperature. Color rendering index is compared here. Start time, striking time in most first 4-5 categories is 0. In case of LED also it is 0. Next is dimming capability. First the lumen maintenance and then dimming capabilities. And this column shows the effect of temperature on performance. This this column compares initial cost of installation. Friends, we'll discuss some of the lamp which are vulnerable even today. One of them is linear fluorescent lamp T5, which has lumen per watt is 80 to 95 watt. Lamp life is 20,000 hours. Electrode color temperature is 2700 to 4100. The color rendering index 75 to 85, very good. Start time 0. Lumen maintenance is 90 to 95%. Dimming capability is available with dimming ballast. Effective temperature, full output only at 35 degrees Celsius. Lower temperature increase start time and light output. Initial cost is medium. After this, we compare metal halide, which have 80 to 90% of efficacy. Lamp life is 10,000 to 20,000 hours. Cathode color temperature is 3,000 to 4,200. Color rendering index 65 to 90. Striking time, it takes 5 to 10 minutes, very high. And lumen maintenance is 80 to 85. Dimming capability, yes, but expensive. Effective temperature, none. Initial cost is high. Then we compare LED. Efficacy varies with the color. Lamp life varies by color up to 1 lakh hours, working hours, very high. Color temperature varies by color. Color rendering index also varies and normally poor but available in higher categories. Start time is 0. Dimming capability with variable power supply only. Effect of temperature, high and low ambient temperature may adversely affect lumen depreciation and life. Initial cost is high. Okay, you can see other also. One of them is induction. very seldom used, but they are available. Friends, this diagram shows the uh, spectrum of visible light, which is from 4000 nanometer wavelength to 700 nanometer wavelength. They are this is enlarged here, and the spectrum is having increased frequency in this one. So ultraviolet is having the highest uh, frequency, whereas infrared region is having uh, low frequency. Some other electromagnetic radiations are also compared. Gamma highest frequency, X-ray next higher, ultraviolet I have discussed, infrared I have discussed, microwave and radio. This particular slide shows spectral distribution of various type of lamp as compared to sunlight. The sunlight is shown with yellow color, and it shows in increasing wavelength order. Incandescent lamp is here. Fluorescent has not very particular linear. Friends, this shows different type of fluorescent lamps and tubes. This is tubular formation. This one is candle type of fluorescent lamp. This is flame type. Its shape gives effect of a flame. This one is A type lamp, and this is glow G type lamp. Color rendering index is a measure of how colors of surface will appear when illuminated by a light source. Friends, light that has an even spectral across the visible spectrum, such as daylight or incandescent lamp, has a high CRI, color rendering index. The maximum is 100. Light that has gaps in SPD has a lower CRI. Friends, this color rendering index. Other useful color measures can be derived from calorimetry. Two of the most commonly used are color rendering index and correlated color temperature CCT. Although these measures are based on color matching, not color appearance, they are also useful for designer and specifier color appearance. Friends, this has the first table shows you color and cathode temperature in degrees Celsius. Incandescent has the lowest, warm white 3000, white 3500, bright white 4000, cool white 4000, and natural daylight has got temperature of 300 Kelvin. These are all temperature in kelvins. Now we will talk about correlated color temperature CCT. Correlated color temperature is a measure of perceiving color of a light source expressed in degrees Kelvin. It corresponds to the temperature of an ideal black body that would emit light of a similar color. CCT is a measure on a scale from 100 uh, 1000 to 10,000 Kelvin, with lower Kelvin values indicating warmer light and higher Kelvin value indicating cooler and bluish light. This concept is crucial for lighting design and selection, as it influences not only how spaces look like but also how people feel, work, rest and move through these spaces. Friends, at lower temperature reddish light is generated. Consider a heating element for an electric oven. As the temperature increases, the light appears to shift from red to reddish yellow to yellowish white to bluish white at high temperatures. Confusingly, light with a CCT correlated color temperature between 2700 Kelvin and 3200 Kelvin is a yellowish white light and described as warm, while light with a CCT between 4000 K and 7000 K is a bluish white light and described as cool. Friends, this figure shows electrode temperature at various electrical sources and their visual effect color. Uh, Koji worm has a this electrode temperature of 2500 degree Kelvin. Halogen like crisp warm white light is having electrode temperature of 3000. Neutral white has 4000. Cool white has 5000 degree Kelvin. Daylight is 6000 Kelvin. C. Color rendering index is the ratio of light sources of a standard reference source. A CRI of over 80 for a fluorescent lamp is considered very good color rendering, while some high pressure sodium lamps have CRI in the range of 20. The color temperature gives a general idea of the visual color of lamp. Warm, more red, 2000 to 3000, or cool, more blue, 4000 K and above Kelvin. While color rendering is how accurately a lamp renders color in the environment. Friends, this table shows you different type of light and their CRI. I will like to discuss T5 lamp, which is available in 14, 21, 28, 35 and 55 watt category, has a good CRI of 100. Metal halide lamp also has very good color rendering, and this is used mostly in sports lighting. Metal halide of another range has got a very high color rendering index. Metal halide master color 35, 70, 150 and 250 watt has also got very good color rendering. LED has got 80 to 90, sodium vapor high pressure 25 very poor, low pressure sodium vapor, very poor. Friends, this uh, has a relevance with color temperature of electrode. For all category of lamps we normally use, and you can see the type of lamp, you can see the color temperature, you can see watt, and you can see lumen rendered by them, and efficacy in lumen per watt in last column. So you can see from this that the 28 watt T5 lamp has 93 lumen per watt category. Friends, the same table continued here for metal halide and sodium vapor lamps. Friends, in the diagram below I have shown a configuration of incandescent lamp. Incandescent lamp technology uses electrical current to heat a coiled tungsten filament to incandescent stage. The glass envelope contains a mixture of nitrogen and a small amount of other inert gases such as argon. Some incandescent lamps such as some flashlight lamp also contain xenon. Incandescent lamps have come up a long way since Thomas Edison's first carbon filament lamp, which when introduced in 1879 had a life of about 40 hours. Today commonly available incandescent lamps have average lives of between 750 to 2000 hours. Thanks once again to Thomas Alva Edison for his great invention, which gave mankind the lighting of today. Friends, now I am describing characteristic feature of incandescent lamps. First, they don't require a ballast. Second, warm color appearance with a low color temperature and excellent color rendering index CRI. Compact light source. Simple maintenance due to screw in addition base. 5. Less efficacious light source. 6. Shorter service life. 7. Filament is sensitive to vibration and jarring. 8. Valve can get very hot during operation, especially the higher voltage one. 9th, must be properly shielded because incandescent lamp can produce direct glare and as a point source. 10th, require proper line voltage as line voltage variations can severely affect light output and severe service life. Friends, now I am describing halogen lamps. Unlike incandescent lamps, halogen lamps use a halogen gas fill, typically iodine or bromine, to produce what is called halogen cycle inside the lamp. In the halogen cycle, halogen gas combines with a tungsten that evaporates from lamp filament, eventually redepositing the tungsten on the filament instead of allowing it to accumulate on the wall as it does in standard incandescent lamps. The tungsten halogen lamp has several differences as compared to incandescent lamp. The lamp has a longer life, 2000 to 3005 hours. The valve wall remains cleaner because the evaporated tungsten is constantly redeposited on the filament by the halogen cycle. This allows the lamp to maintain lumen output throughout its life. The higher operating temperature of the filament improves luminous efficacy. The lamp produces a whiter or cooler light, which has a higher correlated color temperature than a standard inca- incandescent lamp. The bulbs are more compact, offering opportunity for better optical control. But halogen has got a low efficiency as far as power consumption is combined. Here, a number of halogen lamps have been shown in these four different types. Franks, ballast, also called choke by wiremen, are required by both fluorescent and HID lamp. They provide the necessary circuit conditions, voltage, current, and waveform to start and operate the lamp. Two general types of ballast are available for fluorescent lamp. First one is magnetic, second is electronic. Magnetic ballast have disadvantages of power loss of 10 to 25% and of humming noise uh, and magnetic interference and low life. Electronic ballasts are often more expensive but are usually lighter, quieter, and eliminate the lamp flicker associated with magnetic lamp. Friends, now we are discussing fluorescent lamp, which are otherwise low pressure mercury vapor lamp. Fluorescent lighting accounts for two-thirds of all electrical light in the United States and in our country as well. The fluorescent lamp is a gas discharge source that contains mercury vapor at low pressure with a small amount of inert gas for starting. Once an arc is established, the mercury vapor emits ultraviolet radiation. Fluorescent powders coating the inner wall of the glass bulb respond to this ultraviolet radiation, which is known as primary radiation, converting it to secondary emission, which is having wavelength in the visible region of spectrum. Friends, fluorescent lamp are often described in terms of diameter of lamp tube. Diameter is given in eighth of an inch. For example, a T8 lamp has a diameter of 1 inch eighth, while a T5 lamp has a diameter of 5/8 of an inch. Linear fluorescent lamp linear fluorescent range in length from 6 inches to 8 feet. and in diameter from 2 by a eighth half inch, that is 2 lamp, to 2 and 1.5 inches T17 lamp. Their power ranges from 14 to 215 watts. The figure below shows the construction of a linear fluorescent lamp. Oh, this is the lamp and this is the electrode filled with mercury gas. Construction of a linear fluorescent lamp is shown in this one. You have filament on both the sides, then the entire tube filled with mercury vapor, and when this primary emission strikes the surface of the tube, then secondary emission happens, a flow of electrons. The tube is filled with argon and mercury vapor. Friends, compact lamps, otherwise known as CFLs, are almost out of the scene in current scenario and no more being used. But about 15 years ago, they were widely used. CFLs produce light in the same manner as linear fluorescent lamp. Their tube diameter is usually 5 by 8 inch T5 or smaller. CFL power ranges from 5 to 55 watt. Several different type of CFLs are shown here, out of which modular, circular, and the other one are modular twin tubes. This Friends, once again, the characteristic features of fluorescent lamp requires a ballast, range of color, temperature, and color ranging capabilities vary, but in general gives good color rendering, low surface brightness, cooler operation, more efficacious compared to incandescent. Ambient temperature and convection current can affect light output and life. All fixture installed indoor must use a class P ballast that disconnects the ballast in event of being overheat. Eighth, options for starting methods and lamp current loadings. Several options. Requires compatibility with ballast. The last, low temperature can affect starting unless a cold vapor ballast is specified during purchase. Friends, few years back, fluorescent lighting was the best type of lighting for most applications, usually using linear fluorescent lamp. It can be easily controlled and integrated with the daylighting design. Linear fluorescent lamps are classified by tube diameter, wattage, color rendering index, and color temperature and wattage is power required to operate the lamp. The wattage is usually stamped on the lamp itself or on package in which the lamp is shipped. Friends, now we are discussing spectral power distribution, that is SPD. In order to quantify color, The spectrum or wavelength composition of light must be known. A spectral power distribution defines as the radiant power at each wavelength or band of wavelengths in the visible region is typically used to characterize light. Depending on how light is generated by the source, the speed of light can vary from continuous across the visible spectrum to discrete across the spectrum to a narrow band at particular wavelength. For example, light emitted from incandescent filament has a smooth continuous SPD across the visible spectrum, while the light emitted from a fluorescent lamp has an SPD with a low-level continuum with discrete spikes at a specific wavelength. The light emitted from LED has a smooth distribution but is only in a narrow region near one wavelength. Friends, this diagram shows a spectral power distribution curve of some popular lamps. This has on x-axis wavelength and relative energy in 0 to 10 range. This is daylight and broken is natural daylight. This is fluorescent tube. Friends, this particular diagram has spectral power distribution of various lamp types, including incandescent, halogen, fluorescent, HPMV, metal halide, and high pressure sodium vapor. Friends, now we are discussing discharge lamps. Discharge lamps produce light by passing an electrical current through a gas that emits light when ionized by the current. An auxiliary device known as a ballast supplies voltage to the lamp electrodes, which have been coated with a mixture of alkaline earth oxides to enhance electron emission. Two general categories of discharge lamps are used to produce illumination: high intensity discharge lamp and fluorescent lamps. HID lamps are most widely available today in market. First one, high pressure mercury vapor. Second, metal halide. Third, high pressure sodium vapor. Fourth is low pressure sodium vapor. And fifth, xenon lamps. Friends, this shows the circuit diagram as to how the sodium vapor lamp is connected to circuit. We apply 50 hours AC power of 230 volts, and there is a igniter which is necessary for this, and we have a ballast which chooses the voltage color range yellow to red to blue, and this in this particular shows the sodium vapor lamp, and in parallel there is a starting capacitor. Friends, here is the characteristic feature of HID lamp. They require a ballast. Ambient temperature does not affect light output, although low ambient temperature can affect starting, requiring a special type of ballast. It has got compact light source, high lumen package, point light source, range of color temperature and color rendering abilities depending on lamp type, long service life. Its property is highly efficacious in many cases. Ninth, line voltage variations, possible line voltage drops, and circuit size for high starting current requirement must be considered. Friends, now we are discussing high pressure mercury vapor lamp, HPMV lamp. In a high pressure mercury vapor lamp, light is produced by an electric discharge through gaseous mercury. The mercury, often along with argon gas, is contained within a quartz arc tube which is surrounded by an outer valve of borosilicate glass. Xenon may also be used in high pressure mercury vapor lamps to add starting time and does not significantly changing the visible spectrum of the lamp. Friends, this diagram shows the constructional features of a HPMV lamp. Friends, now we are discussing metal halide lamps, which is a mercury vapor lamp with other metal components known as halides added to the arc tube to improve both color and luminous efficacy. Friends, this figure shows constructional features of a metal halide lamp. In this particular metal halide, this one, the arc tube is contained in a surrounding chamber and there are some other features which are added to it. Friends, now we are discussing vulnerable features of LED light emitting diode type lamps. They require a power supply driver, range of white color temperature and RGB color mixing available, energy efficiency saving range of 82% to 93%. They have a long life, no ultraviolet emissions or low infrared emissions. They are durable, they have a small size and design flexibility, they are instantly on type, they are dimmable, they have a very silent operation, no humming noise. T5 lamps, friends, uh, we are discussing T5 type linear lamps. These are the characteristic features. Their discharge is 100 lumen per watt ballast efficacy. They have 40,000 hours rated life on electronic program starter Velas. They have 95% lumen maintenance. They are designed for ambient lighting. They have current color rendering index of 85. Lamp cost is very low. What are the application areas of lighting? LED lighting and LED lamps. They can be used where taking advantage of unique attributes like directionality, they have small size, they have cold temperature performance, improved efficacy and superior optical control. Their application area is outdoor area lighting, down lighting, task lighting, display lighting including refrigeration, cove lighting. What is special about LEDs? First, it is a directional light. Second, low profile, compact size. But remember, they need a heat sink and driver, breakages and vibration resistant, cold temperatures, good near instant on, rapid cycling, many control options, no IR or ultraviolet. Friends, we are discussing now advantages of LED waste solutions. Just to mention, Philips retrofit luminaire master with LED lamps designed to replace halogen and GLS lamp offer energy saving of as much as 80%. Further savings are possible with LED luminaire which are up to 50% more energy efficient than fluorescent solutions. Used together with lighting control, LED based solutions are setting new standards in watts consumed per square meter. In addition, LED eliminate the usage of hazardous substances such as mercury. Also, the material used lasts longer, up to 3 times longer. LED typically have an operation lifetime of 50,000 hours as compared to 15,000 hours of fluorescent lighting. This means that LED light points installed in a new building can often last the entire lifetime of the office, creating even more saving in terms of maintenance. Friends, this shows several options available with LED lighting. Day zone type of fitting is flush with ceiling. Lux space micro and mini square type of fitting used in downlighters. School vision is hanged type of fitting. Day sign is a circular type of fitting. Style lit is a angular spotlight type fitting, and Cove MX power core. All these all are Philips brand, and this is a good street light fitting. Friends, some more Philips make fittings of LED type. This is master LED spotlight fitting. This is Nova Lure fitting, master LED bulb. This fitting is used for spotlighting for grazing purpose, so hence the name of graze power core. This fitting is also a spot floodlight external type with blast power core, and this is circular mini deco floodlighting fixture for external lighting. Friends, once again Philips fitting of several types. This fitting is LED type spotlight fitting. This is LED gene used in street lighting. This also used in street lighting, downlighter type. This is Uni 1 LED pendant type of fitting, and this is another street light fitting, and the last one is a occupancy switch, which is wireless. Friends, now I am describing surface mounted type light fitting. The finished housing is exposed, not flush with the surface. There are several types. One is chandelier light fixture, second is pendant light suspended from ceiling with a chain or pipe. Sconces provide up or down light, can be used to illuminate artwork, architectural details, commonly used in hallways, and are as an alternative to overhead lighting. Then we have track lighting fixture. Individual fixture can be positioned anywhere along with the track, which provides it has inbuilt electrical power source buses. This is under cabinet light mounted below kitchen wall cabinets. 6 categories: emergency lighting or exit light. 7th category is highway low-way lighting downlighters used in industrial buildings. Next is street light or industrial light, often long lines of fluorescent lamps used in a warehouse or factory. The last category is facade lighting. Friends, in this representation, I have shown several type of LED fittings. The first one is single box or batten type. Second is double box batten type of fitting. Third is recessed with open acrylic twin fitting. Fourth is decorative with acrylic diffuser 3 sides. Then this is single trough industrial type. This is trough. This is single tube. This is once again double trough type. This is trough and double tube. This shows twin industrial weatherproof stove enamel type of fitting. The next shows surface mounted sleek LED. This depth is less. Then cove lighting, that means hidden lighting. The lighting source is here, and after reflection it goes some part. So this is recess. This is called recess tray ceiling. Next is double width trough type. We have shown here also. Double louvered type of fitting, surface mounting type. This is square modular recess with acrylic cover. This is acrylic cover. Acrylic is brand name. Next is downlighter LED 12 to 18 watt. These are the heat dissipation fins provided here. And this one shows air lighting. These are the stairs we are climbing, and these are mounted in a cove here, here, or here. Ultimately, friends, for several different type of projects, we have used a special purpose light. First, ascent light we use in most of the office complexes, and background light for use in film television production. Black light is used in theatrical performance. Floodlights are used everywhere for external facade lighting. Safe light for use in dark room. Safety light for use in coal mines. Seventh special type fitting is a searchlight for military and advertising use. Eighth is security lighting. Ninth is step lighting. 10th is strobe lighting. That means audio with visible light. 11th is follow spot for use in theater. 12th is wallbusser. Friends, I am showing here some popular brands of different type of fittings. For fluorescent tube fittings are from Philips, Crompton, Bipro, Havels, Bajaj, Thar, Twinkle, Cashlack, Adanic Highlight with Philips Ballast, General Electric, Anchor or Panasonic. LED type fitting, Cisco, Anchor, Panasonic, and all of above fitting. External perimeter facade lighting, street lighting fittings, sodium vapor, mercury halide type, are from Adanic, Philips, Crompton, Bipro, Bajaj, and Twinkle. Then in post-stop fittings and poles for compound lighting are manufactured by Adanic, Philips, Bajaj, Casalac, Twinkle, Highlight, and Crompton. Next category, electronic ballast are manufactured by Philips, Crompton, Bipro, Havels, Bajaj, Thar, Twinkle, Cashlack, Adanic, Anchor, and Panasonic. Friends, some more points about recessed lighting. This type of ceiling fixture is called so because it is recessed in the ceiling. Simply put, it is installed above it. It is ideal for ambient task and ascent lighting. It helps highlight certain products or merchandise that displays because it focuses on the beam of light onto desired area. It is commonly used in high-end stores, but not exclusively. Any kind of retail store can benefit from this type of light. Recessed lights are also adjustable to certain degree and can be pulled or can come in the form of panel. This pulling feature is provided by Messrs. B Pro. Depending on light bulb of your choice, you can have the option of dimmable lighting also. Friends, this diagram shows various type of downlighters. They can be simply down through. They can have a prismatic reflector. They may be surface mounted. They may be angular mounted, and both type, angular type, mounted type. Friends, this figure shows ascent lighting to increase the performance of exhibits. This figure shows wall washer. They are installed here and they are washing the entire wall. Friends, this slide shows different type of mounting of recess and surface type of fittings. The first one is flush recessed. It is flushed and fitting is deep inside. The second one is exposed canister. It is recessed, but this canister is provided to downward lighting. This feature is eye wall type down spotlight. This is adjustable spotlight. This is pendant type light. This one is real type. This is recess flush light panel. This shows suspended luminary. This shows full room luminous ceiling. This one. This shows surface mounted luminary. This one. This shows track lighting. This shows surface mounted fixture. This shows coffered light recess type. This is coffering. The coffered light goes like this, and after reflection it is spread. Then this last one shows suspended hanging type fittings.